Guten Morgen. Is it right? Yeah. Guten Morgen.
Goedemorgen.
Beste collega's. And welcome to the first episode of Show Me Your REPL. So we all Clojurians, we all love the Clojure REPL, but this is kind of skill and art to interactively write the code, yes? So, and this is a screencast where the experienced programmers will show how they do it. Yeah, and our first guest, I don't think he needs any introductions because this is our Clojure hero, Michiel Borkent. Yes, the guy behind the Clojure Condo, Babashka, I don't know, simple interpreter, a lot of stuff. I'm pretty sure you're using his libraries and tooling. So hi, Michiel.
Thank you for having me. It's Nikolai. It's a pleasure to be in the first episode. That's a real honor.
And thank you that you're here. Yeah, and let's start, maybe from the first question that newcomers have it, not only newcomers, how we set up the project. Maybe tell a little bit about your tools around and the editor you're using, and then run the REPL Connect and show us how to do it. Yeah, let's share the screen. Yeah.
Okay, I'll share my screen. So I'm using Emacs. It's probably not the most beginner-friendly option, but I'll just show what I'm using.
Yeah, but maybe you can tell why you prefer Emacs, because it's idiomatic editor, yes?
Of course, yeah. Well, I started using Clojure in 2010, and around then there weren't many alternatives for Clojure. So the reason I started using Emacs was to have the best Clojure environment, and that was Emacs at the time. But today that's no longer necessarily the case. So if you're just starting out, learning Clojure and Emacs can be a little bit intimidating, but that's no longer necessary. There are good alternatives available today. So the idea that I had was, so there is each year there is a contest called, or not a contest, but just a collection of puzzles that you can do called Advent of Code. And last year I only did a few, but a few years ago I did them all, but it can be quite addicting. But I will show how to make a new project so you can set up like a project to do these puzzles if you enjoy that. And I will show how to do that in the REPL as well. So the tool that I'm using is to make a new project. I usually do it from the terminal.
Mm-hmm.
So I'll zoom in.
Just and tell me if you're using ZSH, yes, and
I'm using ZSH and iTerm2 on Mac OS X or Mac OS. And every time I start a terminal, I have a little script, Babashka script, which prints the docstring of the day. So if I open a new terminal, I will see a new docstring. So that's just a funny docstring. Oh yeah, random doc. So here it is in my ZSH config. I have the script in Dropbox, so it will synchronize on all my machines, but just a detail.
Mm-hmm.
And so the script is only this. So user NBB that takes care of starting with Babashka, and then it has a macro called random doc, and it takes all the public vars from Clojure Core, and then it looks at the doc metadata. If it has the doc metadata, then I just execute the doc macro from the Clojure REPL namespace, and if it doesn't have doc metadata, then I try the next one. So that's all.
Awesome.
So if I random doc, so yeah, so that's what happens in my shell.
Yeah, that's so cool.
Okay, so to set up a new project, I have a tool called Neil, and maybe it's good to show that as well. Neil. So Neil is a little, or not a little. It's now quite advanced, but it's a Babashka script to reduce boilerplate in your projects and also to set up new projects. So the way it looks, if you execute Neil, or you can install it with brew, for example, and if you then type Neil like this, it will show you what to do. But so you can add dependencies to your project, add tools.build script to your project, etc. But for creating new projects, there is the new command. So when I type new and then help, you can see it prints the way you can set up a new project, but it actually uses Sean Corfield deps new under the hood, which is also compatible with Babashka. But just to start with the simplest option, I just do Neil new scratch, which is an empty project basically. Well, I don't always use Neil for this, so I usually just create a source directory and then a file in the source directory. But you can, if you use Neil, then it's a little bit less work.
So and how many new projects are you starting in a week, let's say?
Well, I don't know if
there is a so that how
regular
many how many times you created the source directory last week?
Well, I do this often to try and debug things. So I did it at least once this week for a GraalVM issue. So I usually do this in the temp directory. So I have a Graal test project here. So I have a source folder here. Test Clojure. Graal. So, and there was an issue with a logging library with GraalVM. So I just made a reproduction this way. So it's just source and then, well, but we can do it with the Neil new scratch. And then the name of the project, let's do Advent of Code 22. And then that's all. So if you see what files are in here, oh, I don't even have the tree command. Well, AOC, like this, okay. So deps Eden, so it generates a deps Eden for you, and a source directory with just this file. And if you look in the deps Eden, you see that Neil also inserts some information, like the project name. And this can be used if you make a jar or uberjar, then it will pick up on this name, but that's not what we're doing today. So then I open this project in the editor. And then what happens here, I don't know if you can see it, it's a little bit small, but this is actually Clojure LSP asking me to import the project, or not Clojure LSP, but just a LSP plugin for Emacs. And LSP allows you to navigate in your project and linting and stuff like that. So.
And one more question. So are you using some Emacs build like Space Max? So I see Prelude, yes. So
yeah, I use Prelude from Bojidar. This is a fork of Bojidar's Prelude. So the way you use, so Prelude is an Emacs starter kit with some presets that are, well, if you're starting out with Emacs like I did 10 years ago, it's very handy to start with someone else's configuration. And that's what I did, and I'm still using it today. So the way you use this is you just fork it, and then you clone it locally in your Emacs directory, and that's it. And then you can make changes, and regularly you can like pull from the upstream to have the latest changes. It doesn't change that often, which is quite good because then I also don't have to change a lot.
Mm-hmm. And are you Emacs fingerstyle or VI?
I don't use the VI key bindings.
Okay.
Yeah, a lot of people do, but I haven't had any interest in that yet. So
Okay.
I hear a lot of good things about it, so maybe I should try it, but I just haven't. So advent of code. So I will just call this namespace day1. And then you will see here lint warning, like the namespace name does not match with the file. And this is coming from CLJ Condo, the Clojure linter that I'm also the author of. And this is actually part of Clojure LSP. So all the static the static analysis that is done in this project is that Clojure LSP uses is done by CLJ Condo. So you get linting, but you also get navigation. So if I make a comment form here and I do exec something and I navigate to this, you see that my cursor goes to this function. Well, I'm not connected to a REPL yet, but this is just because Clojure LSP has this information available where this exec function is.
Can Clojure LSP navigate into the standard library functions if you...
Yes. So if I do a print line and I do navigate, then I end up in the Clojure.
Okay.
Yeah.
So in Emacs, it's a go to definition command, yes?
Yeah. Okay, but we have to fix this. So namespace name. So I go into dir add. It's called in Emacs. The directory editor, I believe. So I just changed the name of this file to day01. So now if I make an edit, then you see, okay, it's gone. Okay. So exec. So there is an example here that you can invoke this function with Clojure -x. But I have to fix this, of course, this name as well. So you can execute this function on the command line if you want, using this command. And let me try that. So exec with nil, but you can give it some options, foo1. So now you see, okay, you can pass some options to it. For advent of code, we're maybe not so much interested in these options, but you can do it. But the way you can execute a function from the command line is just you pass it a map, or if you don't pass any arguments, then you get the empty map here. Okay, so here we can do like part 1 of our advent of code puzzle, and here we can do part 2. I'll remove this. Okay. Okay. And it would also be nice to do the puzzles with Babashka and Clojure, right?
Yeah.
Because last year some people have also used Babashka for advent of code, so I also want to show how you can execute the same function with Babashka. Day1, part 1. But this doesn't work yet. So if I try it, then it says I could not find the namespace.
Yeah.
And the way we can fix that is we go to the root of the directory and we make a bb eden file, which is for Babashka, which is similar to deps.eden. So in deps.eden, we have this paths option, which says where the source files are. And we do the same for Babashka, then it will probably work. So if I now print something in this function, hello part 1, you see that it works. And now with Clojure, it's the same.
Yeah, and we see the difference in start time. Yes.
Yeah. So the
Progress.
difference is so Babashka it's 17 milliseconds, and for Clojure it's
Yeah,
time. For Clojure it's 700 milliseconds. Okay.
Mhm.
So Babashka is really made for scripting. If you want to have fast startup for some scripts written in Clojure, like you would do for Bash, then that's the use case for Babashka. It doesn't support everything in Clojure, but it supports a lot. So and a lot of libraries also work with Babashka. So let's see. So if we're going to do Advent of Code, then we need. So I'm not going to actually solve the puzzle in this video because that takes too long. But so how it works with Advent of Code is that you get an input, and then they have a like story around this, what you should do with this input, and then you should program something, and then there is an answer, and then you can fill in the answer, and then it says if it's correct or not.
Mhm.
So this is my puzzle input. So let's download it. And yes. So dev AOC 22. But it's a good tradition in the Clojure projects to put like files, like text files and stuff like that, in a folder called resources. So we can do it like this, day one in resources. But to be able to read it, you can do it like this, input slurp day one text. But now this will fail because the resources directory is not on the class path by default. Or you can actually do it just like this. So it will read from the current directory, but the way we usually do it in Clojure is via IO resource. And you also saw that Clojure LSP adds automatically this this lib spec to the require clauses if I type IO slash. But this will still fail because resources directory is not on my class path yet. So I can fix that by adding resources here. And also for BB Eden. And now let's see if I go back. So let me print like part of the input, the first 10 characters of the input. So oh, that's quite a lot.
Mhm.
Oh, I probably should do it like this. Okay, so these are the first 10 characters of the input. You see it's all numbers. So what we should actually do is split.
But I think that's how Python programmers do programming. Yes. So let's maybe start the REPL.
Yes, yes. I will show how to connect to a REPL.
Yeah.
In a minute. But I just so this is just the project setup.
Yeah.
So we split the lines and then we do map parse int or parse long. And then we have the input and then I print like the take 10 of the input. Okay, and then I will start the REPL. That's a good point. Okay, parse long. Oh yeah, so I should do it like this. Okay, you see that it works. So we have 10 numbers. But of course, we want to use the REPL. So how I usually start a REPL is Cider is, you can do it in two ways. So Cider is the Clojure REPL environment for in Emacs for and you can start either the REPL from the editor, or you can start the REPL here and then connect from the editor. I can show both ways. So Neil also has a command called neil add REPL. Or what was it? Neil add nREPL. Oh yeah.
Mm-hmm.
Neil add nREPL. And what it does, it adds an alias to your depth Eden. And you can then start Clojure a or actually nREPL. That's then you will start this main command. And now you it has an nREPL server running on this port. And then I can do in my editor cider connect localhost. And it already knows the port because there is some file on disk which has the port. So now I'm in my editor, and what a lot of people do is when they're just starting out, they try typing in this window, but that's actually what you should not do or should try to prevent. So you can type Clojure expressions here, system get property user there. Then you see, okay, I'm in my AOC directory. But what you should actually do is evaluate from your file. So, and a lot of people use like a rich comment block or comment form. So you can evaluate expressions from here. So that's Control X E, what I'm typing.
Mm-hmm.
And that means evaluate the form before my cursor. And so you can evaluate things in here, but the comment form, if it's evaluated by Clojure, like from the top level, this is just ignored. So that's the idea of the comment form. Everything in here is ignored, except of course if you're trying to evaluate something in your nREPL session here. So that's pretty neat. Oh, and here I'm trying to evaluate this, but the issue is that I haven't evaluated this yet. And this is why you see the error here. It says, what did it say? Let me do it again. It says, unable to resolve symbol input. So the way I can solve this is just evaluate the whole file, which is Control-C, Control-K. And now everything is evaluated, and so that works. Okay. So the other way, so if you don't have this this alias, so there is a benefit of starting the nREPL from outside your editor, because if your editor crashes or you quit it, then this session lives on and you can reconnect from your editor the next time. So if you're running a heavy process that takes long to start, you want to run it multiple days, I think it's usually better to start it from outside your editor, because if you want to reboot your editor, then you lose all your state.
Yeah, sometimes you even can kind of start this server, connect through SSH to remote server and connect to REPL. Yes, this is magic you can do.
Yeah. So yeah, that's the magic of nREPL. It can even run on a different computer, and that's indeed what you can do. So you can connect from your local code to a server and then evaluate expressions on the server. But if you don't want to, if you don't care about losing your state, so I've now quit the nREPL. There's also something in Cider called Cider Jack-in. And here it will say, okay, what command should I use? The Clojure CLI, okay. And then it will automatically call the right, or it will add the right dependencies for itself to start NREPL. So now I'm in a new NREPL session again. And so that's pretty convenient if you don't care about losing your state too much. Okay, that's how you do a REPL for Clojure. There is also a way to, let me do cider quit first. Quit. If you want to do it with Babashka, that's also possible. So there is also cider jack in or Babashka. Now I'm actually connected to Babashka and not the Clojure JVM. So how do I know? By executing this get property just babashka.version. So Babashka also has a built-in NREPL server that you can use for developing. And so cider quit. And if you, well, you can also start it from the command line here. So it's the same mechanism that you saw before. Okay, so let's get back into the REPL. So this is how you can solve the puzzles in the REPL. We have the input here. Let's see. And now I will just give a dummy like solution. This is not the correct answer, of course, but you should figure that out by yourself if you want to do the puzzles. And now, okay, say that you don't have a REPL. No. Let's make some. Maybe it's fun to make a test runner that
Yeah,
you can also
show us your classic workflow. Yeah, so let's say you're writing the production code. So I'm pretty sure you're a test-driven guy.
Okay. So this is our production code, and now we want to write some tests. Okay. So what you can do with Neil again is Neil add test, and then it will make a test directory with one test file, and it will also add a test alias to the project, and it uses the Cognitect Labs test runner. I can show that test runner. This one. And it's pretty basic test runner for Clojure, which works with the Debs Eden tooling. And there, it's quite neat. There is also a Clojure script version of this, which I use a lot. It's called Sail.js Test Runner. It's this one. And it has pretty much the same interface. So it's pretty neat that you can run your test for Clojure and Clojure script with the same, with the same commands. So
is this your preferred test runner, or you are using Coucha sometimes or something else?
Yeah, so Neil also has support for Neil at Coucha, I think they pronounce it. I haven't used Coucha a lot myself, so I usually use the Cognitect test runner, or when I have the Leiningen project, which I still use in some places, I just use line test, which is the built-in test runner for Leiningen. But Coucha is more like, how I understand it, it's more like a testing framework with all kinds of plugins and stuff.
Yeah, it has a lot of plugins.
Yeah. And but running Clojure script with Coucha is a little bit complicated, I think. So that's why I stuck with just a basic test runner, which does the same thing for both the platforms. All right, so let's write a test. Test advent of code, and we call it day 1 test. So again, we should change this file. Day 1 test. And then we make this day 1 test. To do fix, of course. So now we require the namespace that we want to test is AOC day 1. Refer part 1 and part 2. So now we say is part 1. So we have one argument which we ignore. We just pass an empty map. And then we state that it should return 1337, which is not the case. So this test will fail. So let's see how it will fail on if we execute it from the command line. That is what you usually will do in CI. If you run the test in CI, then you type Clojure -x or -m test. So you can see, okay, this test is failing. It has 199 instead of 1337. So, okay, 199 then. And we can run it again. Okay, now it succeeds. And the same for part 2. Part 2 works. Oh. Well, we call this part 1. Part 2. Part 1 works. Part 2 works. Let's see how it fails this time. Okay, so this is 227. Okay, these things work. So it says unsorted namespace. That's because it's not by default turned on, this linter. But I have in my personal configuration for SailJCondo, I have this unsorted required namespaces level warning. So that's not turned on, but I find it quite useful. And then there is a refactoring in Clojure LSP, which is called LSP organized namespace or something. Organize imports. Then it will sort it automatically for me. So. And
why is it important? Because of merge conflicts? So it's
it's not that important, but I just find it easier to find. So if you have a lot of namespaces, it's easier to find something. And
I can imagine that if there's a merge conflict, yes, so then it's maybe better as well.
Yeah. For merge conflicts, it's probably easier to have it in there.
And let's talk maybe a little bit about how to properly write require session. What is your recommendation? I see you're using refer and S. Yes, so
yeah.
So there's a refer all, which is, I think, should be considered as anti-pattern.
Yeah, so there is a refer all, so you can do refer all here.
Yeah.
But SailJCondo recommends that you don't use this because there are actually 2 reasons, or 3 maybe. I personally find it harder to read where things are coming from. So if you write refer dev test is testing, I know that this is coming from Clojure test, but now I kind of have to guess. Especially when you're new to an API, it's not so clear where things are coming from. And also, if you have multiple refer alls, it gets even more confusing. And recently, I even found like a situation. Where was it again? It was with a library that also used refer all.
And bring to some conflicts of dependency.
Yeah, there was some conflict. What was it? The library. So we've just integrant, I think. So there was, yeah. So if you use integrant with Clojure 1.11, Clojure 1.11 has a new bar in Clojure test, run test. But this project already had a run test function in the test namespace, so this actually crashed because it was already being defined. So it's like this. So if I do run test 1, oh yeah.
Yeah, we see it. Run test.
So yeah, that's the same error. So if you upgrade from Clojure 1.10 to 1.11, you will have this this error. And Celtic also warns you about this, I believe. But yeah, so I think all in all, it's better to use just an alias and explicit refers. And oh yeah, the other reason is in Clojure script, refer all also doesn't work. So so if you want to keep your code more compatible across dialects, it's also better to just ignore refer all, I think.
And how to choose between the alias and the refer? So when you pick the refer and when you pick the alias?
Yeah, it's a little bit subjective, but I usually, in test namespaces, I usually refer these 3 because I use them a lot. And for other things, I use the alias. So if I want to run the test from the REPL, I just use run tests, then the name of this namespace, for example. So now I run the tests. Should evaluate them all at first. And now you see, okay, I have 2 tests are run now. So this is where I use the alias usually. I know that Cider also has things for running tests.
Yeah, it has. You can call it meta X.
But I usually don't use that. I usually just.
Yeah, it's very nice. I can tell you when.
Oh, so well, tell me how do I do that?
So if you first of all, if you switch to the source code file, yes, you can still run the tests. So the Cider is quite smart. So you can jump here and say Cider run namespace test, and it will run the tests. And it has quite nice reporter where you can jump to the problem position.
So tell me what to do now.
Yeah, so search for the command. Cider run tests. Yeah.
Cider run test. Test run test.
Yeah, I think run ns tests. Yes, so we are in namespace.
Run ns. Oh yeah, okay. Run ns tests.
Yeah.
Oh yeah.
And you see
it works.
the green. Yeah.
Under. I saw it.
Yeah. And then do you have the quick jump from source file to test? Do you use it?
No.
It's a feature of Projectile. You can jump with a 1K press between the source file and the test. So jumping very quickly. So it's done by Bojidar as well. So it's very nice workflow when you're jumping between the 2 files and then you write the tests. It fails. Then you jump to the source file, starting writing, and like between your typing, you're running this test and see this green or red bar at the bottom. And if there any error, you can jump. It has quite nice reporting, so you can jump to exactly to the problems position. Yeah.
What I usually do is I use LSP find references. Then I can see, okay, here, this is it's maybe a little bit slower, but it works for me. And so, but I usually just, don't rely on this more sophisticated things. So I just usually do it like this. And so Clojure now also has a macro run test where you can just run a single test. This is new in Clojure 1.11. All right. So this is how you can run tests from REPL, and with the more sophisticated tooling Insider, okay, it gets even better. But in CI, you will just execute this, and if you want to execute a single test, you can do it like this. You can do the name of the namespace, and then the part1 test, the name of the var. So now you can see it only executes one test. So if you want to execute advent of code puzzle, let's say from the command line, you can via the test, you can also do it run a single one like this. So that's, yeah, I think that's pretty much it. Oh yeah, so with Babashka, you can use the same test runner, but it requires a little bit more. It requires one workaround currently. So let me show that as well. So the tests, so you need the same dependency, the test runner. BB Eden. So you can do deps. And then Babashka has a task runner. So you can say tasks. And then you can give it a name, like test BB. So let's do a dummy first. Print line running BB tests. Oh yeah, and we will make one for Clojure. Test Clojure. Running CLJ tests. So the idea of the task runner is that you can type things from the command line to execute things for your project. So kind of like a make file. So if I now type BB tasks, then it says the following tasks are available: test CLJ and test BB. And I can also add a documentation to that. So this is the task, and this is my documentation. So I will move this string here. Run Clojure tests. And the same for BB. Task, doc, run BB tests. So if I now execute this from the command line again, you will see that it has this doc string it will print. So let's test it. So you can have auto completion for this. So I press tab and then it says BB or CLJ. So now it says running BB tests, and now here it says running Clojure tests. So the way we did ran the Clojure tests was with Clojure M. So Babashka tasks has a built-in Clojure function, which executes the Clojure CLI. You don't have to have a pre-installed Clojure CLI for it. So it has a built-in implementation of the Clojure CLI that it will use. Now you can do M tests. So you don't have to remember this how to do this. So you can, or it actually, I wanted to do that here because it's the Clojure tests. So let's try it. Now it will run the Clojure tests. So it does the same thing as Clojure M test, but now we don't have to remember how to do it. We can just type Babashka tasks and then BB tests. Okay, so that's easier to remember also in in CI configurations like that. So for Babashka, how do we execute the tests? So we have the test runner here, and we can require the test runner. What was the name again? I have to look that up.
I think Clojure test.
Yeah, namespace. Anyway, let's see. Oh, here, of course. Cognitect test run. That's the main namespace. So actually, yeah, okay. str, for example. And now we can do, I will execute tr main, but I will actually pass the command line arguments to it. But there is one problem, that there is a dependency in this test runner that is not compatible with Babashka. I will show what happens now. Test BB. So yeah, there is Clojure tools reader in here, which currently doesn't work with Babashka. But there is a solution, because I'm working on a better solution, but there is tools namespace. All right. So I have a dependency, which is a fork of Clojure tools namespace, which is used in the test runner, which is compatible with Babashka. So if you insert that in your dependencies, then
what was the problem? I mean, in original.
Yeah, the original problem is that
some Java.
So tools reader has let's see. Yeah, it's a little bit technical to explain it, but the problem is, if you want to execute this from source, there are these dev types which implement Java interfaces.
Okay.
And this is one limitation in Babashka right now, that you cannot create new types with arbitrary Java interfaces. So that's the limitation that I hit. So if I add this to my dependencies as well, and I actually want to make this more smooth. So maybe by the time this year, when Advent of Code starts, I have a more nicer solution for this. But now it should work, actually. No, it doesn't. Oh yeah, there is one more issue. I should also add the tests to the class path. And let's see. Okay, now it worked. So you see that it's very fast as well. So it's only 38 milliseconds.
Yeah, that's amazing. So you can write the tests for your scripts.
Yeah, you can write the tests for your scripts. You don't have to use this test runner. You can also just use Clojure test and then do it manually, like I did here. You can, we can make a manual runner to show how that is done. So let me do that. So I'll make a manual test runner without like the Cognitect library. So require Clojure tests st, and then aoc.22.day0 test. And now I make a main function, and we just call trun tests on this namespace. So, and you have to do this for every namespace, or you can do it like with a more dynamic approach. Okay, this works. And we will ignore the arguments for now. Organize imports. So what I can do now is do bb, or let's do it with Clojure first. CLJ minus m, and then m. That is how you execute a main function. And now with this thing, but the problem is that we don't have the test directory on the class path. So now it will say, okay, I could not locate this. So this is what the test runner will actually also do for you normally, that it adds the test directory to the class path. Or No, that's actually in the alias. So you see the test alias, and it says extra paths test. So let me make another alias test runner, just to show how you can do this yourself. It's maybe extra paths test, then main ops. What is it? This one minus m. This one. So if I now do Clojure minus m test runner, it should execute my test runner. You see? So this is from scratch. But there is one issue. So if I make a failing test, so I change this test to make it fail. You see that it complains here that the test failed, but if I look at the exit code program, it's still 0. So that's what I should fix in my runner. So there is a result here. Fail error. Like this. And so when they're both there and the result of adding this is positive, then I do system exit 1. Okay, so now this should be fixed. Yeah, that works. And also, when I want to execute this with Babashka, which should also be possible, it's pretty simple. I can do task. Actually, AOC. This is the only thing that I think that you need to specify. BB test BB. Yeah, that works.
Awesome.
So if you just put a symbol here, it will interpret that as a main function that it calls with the command line arguments. So we can switch to that test runner. Now we have made our own test runner, but so if you want to do this manually, like print something before it, we can still do that. Then you actually need to do some more work. Let's say requires AOC runner as runner or something. And then we do apply our main command line args. Like this. Or running BB tests, actually.
Any place to see the good Babashka tasks, how to say, templates, to see how, is it your open source project or do you have the collection of tasks? Because there are many common tasks, yes?
Oh, yeah. Yeah, so you can just use any library in here. So it works just like libraries, actually, that you can just call functions in here. So there's not so tasks are more like project specific, and where you can use libraries to do your project specific things.
That's awesome. And for your open source project, what kind of CI do you prefer?
Yeah,
how it's configured?
Yeah. It depends a little bit. So if it's just a lightweight project like this, I tend to go with GitHub Actions right now. But some projects require something more. For example, Babashka, it has to be compiled for Mac OS, ARM 64, and things like that, which is not supported by GitHub Actions. And there I use another service And I also use Circle CI in there because I have access to better hardware there. So, but for normal, like lightweight projects like this, I think GitHub Actions is actually more than enough. So we can show how to do that. So you make a .github directory and then workflows. Then I call it ci.yaml, for example. So, and where I usually start is there is a project called setup Clojure, which is a GitHub action that you can use to set up Clojure projects. And you can also install Babashka with it. So I just copy this usually and start from there. And then remove things that I don't need. So let's see. So name CI on push. I usually add pull requests to this, so it also runs on pull requests. It installs Java, which is fine, and I only need Babashka, and I just say latest here because I just want to have the latest version always. And then here the caching is fine. And here we execute Clojure tests. Then I say, okay, bb test CLJ. And here, okay, we can copy this, execute bb tests, test bb. And this is all we need. So the rest I remove. Actually, I need to first, of course, make a GitHub project for
maybe let's skip, but I think that's enough for the guys to understand. So you will create the project, you will commit, and it will work. Yes, just
this will just work. Yeah.
This is interesting topic because so Babashka is compiled with Graal, yes, so providing binary, and I see. So maybe some tips how to build such utils because so you go this way, you set up all the environment, yes, but I see the people trying to build utils as well with the Graal, and what the tips are, or where to see how to set up it properly. I mean, builds for different architectures.
So so GitHub Actions is also suited for this. You can compile with Linux, Mac, and Windows, but it just doesn't support ARM64 Mac yet, and also not the ARM64 for Linux. So, but if you want to support that, you need to use different CI environments. But I can show how to compile with GraalVM just for this example. So let's say we have a main function here, and we print the output of part 1 and then we print the output of part 2. And we go, so if we do Clojure -m this, resources. I think I still need to add resources to my dep seed. No.
I think that there is no folder. You created this. Yeah.
What was the issue again? Clojure. -m. Yeah, that's confusing. So the main function, you have to insert another -m here. Okay, but suppose that we want to, and for Babashka it works the same. But suppose that we want to create a GraalVM binary from this, right?
Yeah.
That runs this. Okay. What you can do is, so what I have on my machine is GraalVM home. There I have the Graal download, the GraalVM distribution. I always use this environment variable, so I know where it is. Also on the CI. And if I want to use a different version of GraalVM, I just change this environment variable. Right now it's Java 11.22.3, but I can easily change this to Java 19 or something, which I also have on my machine. And GraalVM has a command called native image, that you can use to compile Clojure to a native binary. And I usually do this via a jar file. So then we first need to create an Uber jar from this. So, and then you can say jar and then the jar file. And you will need some other options, but I can show that as well. So we first need to create an Uber jar. So what you can do is, for this is nil add build, which adds a tool.tools.build configuration. And so this is just a bunch of boilerplate that you need for creating an Uber jar. And we just need to change the main namespace here somewhere, I think. So let's go in there. Build. So yeah, let's see. Maybe what's the main?
I think this mylib one or not at the top.
Yes. Well, let's just see what happens if we try it. So the way you do this is Clojure -t build and then Uber. Okay, now it created something in the target directory, which is AOC standalone jar. So if we execute this with Java -jar, then it says no main attribute. So I think we need to go to the documentation, tools build API or something. Let's see. API and then Uber. And there it says, okay, main class symbol. So we should just use that. We add it here, main AOC 22 day one. Oh, it's a symbol, yeah, which I should quote. Now I try it again, and it will fail for a different reason, but I will explain it when we see it. So now it says I could not load main class because there is not, yeah, you should add again class thing to it. So it generates a class for this entry point. So let's try it again. And probably it will still won't work. Oh, it does work. Yeah, okay. Yeah, because it will compile probably, yeah, it will compile this entry point. Okay. So now we have the jar that we need to use with native image. So if I do GraalVM home and then bin native image and then -jar, this will actually also fail. And here's the name of the executable. Let's call it like this. This will fail because Clojure requires some extra configuration for native image. So you have to actually initialize stuff at build time for Clojure, else it won't work. Because Clojure does a lot of things dynamically, and that's problematic with GraalVM. Oh, yeah. And I don't want a fallback image because that is basically no fallback. That is basically just full-blown JVM without good startup. So that's never what we want. But just to shortcut a little bit, you need to do something like this. Clojure and also AOC 22. So let's see build time. And I think now it should more or less start working.
This sounds like ahead of time compilation, yes? Which is classes, yes. So Graal requires these ahead of time compiled classes, yes?
Yes. So what we did in the Uberjar is everything is already compiled to class files. That is one thing that Graal needs. And then what Graal does is it compiles those class files to machine code. So now we have a binary which works. So this is our standalone binary.
Nice. What's the size of the binary?
Let's see. It's 12 megabytes, which is okay. Yeah. So that's the quickest way. But of course, we don't want to remember all of this stuff. So we can put it in the BB Eden task. So maybe that's a nice way to close today. So we do the native image. And we have, create native image. And the task is shell, which is a built-in function to shell out. And GraalVM home. So it's not bash actually. So you have to get this environment variable yourself. So let's Graal home system get env GraalVM home. Now we can do format, or actually native image bin. So there is a library in Babashka called FS. And it also runs with the JVM, so you can also use it on the JVM, of course. So we can do, to make it cross-platform, you can do GraalVM home bin native image. Because if you use slashes, it won't work well on Windows. So this is our native image. And now we can do native image bin, or just call it native image. Yeah. And then we have these arguments. But you need to split them like this. So fallback. And then this one. Okay, let's make it a little bit this. And of course you can put documentation like binary name like this. And there is a utility library for this initialize at build time thing. It's called Graal build time. So it's actually better to start using this if you're getting serious about like more dependencies in your project. It will automatically configure native image that it will insert this argument for you, so you don't have to think about this anymore. Let's see. Oh, yeah, the only thing required for that is actually to have it on your class path. So if you're building the Uber jar for native image, you can just add it to your dependency, and then it should work. But I'll skip that for now. So this should work. So if you now type pp native image, then it should start compiling. I will skip it. But we did need the Uber jar, right? So this task actually depends on the Uber jar being there. So we can make a new task, and that is Clojure build Uber, like this. Or you can do it in one string. So the first string is chopped up in separate things, so you don't have to separate it, but it's optional. And then we can say, okay, this task actually depends on UberJar. So if I now do native image, we will see that it first produces the UberJar, but we are actually not outputting anything. So we don't see that it does it. So we can maybe do a print line in here, like print line creating UberJar, and then here print line done creating UberJar. So now I will do it again, and then we will see that it actually does this first. And there are some tricks to skip this. If the UberJar is already there, you can do that also with Babashka FS. So you can say if FS, what was the trick again? So I have a blog about this, speeding up builds. FS Clojure. Yeah, FS modified since. So there, it's on my blog how to use this. So if FS modified since, then you say the file. So the file is this UberJar. Oh. And so if for example, if the source directory hasn't changed, or if the UberJar is newer than all the files in the source directory, then we will execute this step, and else we will assume that it's already there.
Yeah.
So if I now execute bb native image again, then we will probably see that, oh, now it does create it. Oh yeah. I know what's wrong. This returns a seek, so you have to call seek on it. Oh, still. Okay, let's see what's going on here.
Yeah, we have a REPL.
We have a REPL, yeah. So you can do this in outside the REPL or inside the REPL, but then we need to create a Clojure file. And okay, but yeah, we can actually do it in a REPL. Yeah, why not? So for now I will do it on the console because it's quicker this way to debug this. But okay, so there is actually one file that is newer than UberJar. That's funny. Why is that?
That's interesting.
That's interesting. Okay.
Maybe it's a bug.
So
Modified.
maybe. Oh, I hope not. Let's see. ls source. This is from 12.14 and target. Oh, I know what's wrong. I don't see the ubijar here. Oh, let's try this bb ubijar to make sure it's there, right? So now it's there.
Yeah.
And if I in the REPL execute this again, then it's empty. So okay, that should work. So let's go. Let's do bb native image. But why?
Looks like something removing the Uber.
Yeah, something cleans. Oh yeah, I know what it is. So bb in build. Actually, we call clean first here, so it removes the
Uber.
Okay, well, okay, but you can figure it out.
Yes, so you can write your own logic. Yes, for how you.
Yeah, you can optimize this for time, like skip things and stuff like that. So okay, but let's keep it simple for now. And so this is the ubijar task, and now when we execute native image, it depends on ubijar. So it first executes this one, and then it does this. So that's how you can do things. If there is too much code in here, I usually move this to a file. So then I start a bb directory with a tasks file. So this is ns tasks. Then I move this code to here. Then I just make it a function. Okay, require Babashka fs. And make it a function like native, native image like this. In GraalVM home, yeah. So the shell we can import from Babashka process. Okay, and now we have a function. So it's nicer. You can also use this from the REPL, of course.
Yeah.
And now we say, okay, requires, well, you can, these are the global requires for all our tasks. Well, we can just call it tasks, but we have to add the bb directory to the class path. So now we can say tasks native image with whatever options. Now it should still work. And also we get linting, etc. inside of the file, of course. But it still works. And now we have also linting here. So if we make typos and stuff like that, then it's a little bit nicer to not code too much in here, because it gets a little bit out of control. And you can use the REPL again. So if I can do cider jack in, no, cider quit. I have my previous REPL still running. So cider jack in, Babashka, and now so I can evaluate this and I can try it out. I can call native image from here and just experiment with it. So yeah, that's pretty nice so you have this make file kind of thing, but you can connect it to your Clojure code that way. So yeah.
Yeah, that's awesome. Thank you. I think we already spent an hour and just discussed the small part what we planned, but maybe we should do the next episode. So, are you tired? So let's finish this. So maybe just to finish, what the next amazing stuff is going on in the world of Clojure tooling and libraries. So what's your plans? Maybe some new library or new tool.
Yeah, I'm still working on Babashka and Sail.Condo, so those are going to be improved over time, of course. And Babashka recently has gotten a new library that it's called Babashka CLI, and you can make nice CLIs with this. And but that's already in here, so that's not in the future, but it's already in here, but relatively new. But I'm currently also working on JavaScript stuff. So the interpreter that is in Babashka, it's called Sai, and Sai also works in JavaScript. And there is one tool called NBB. So you can do npm install NBB in your project. And it's kind of like Babashka, but for Node.js. So if you do npx NBB, you will be dropped in a REPL, NBB REPL, and there you can do like a fs. This is Node built-in library. Read file sync deps Eden. So, and this is just Node.js, but it's similar. So that also already exists. But I'm also working on a new compiler for ClojureScript. And that is more experimental and for the future.
What the key idea of this new compiler?
And the key ideas in this compiler is that you can use it from the Clojure or from the JavaScript side, tooling side. So you can do npm install Cherry. That is one of the things I'm working on, which is like a more focused ClojureScript compiler. npx Cherry Sail.js assoc bar, and now I can just run it from Node.
So you don't need JVM, yes, to compile it.
You don't need the JVM anymore. So it's all, you can use it on the JVM, and it even works in Babashka. So I can compile JavaScript in Babashka using Cherry. I can do nil add dep. I think it's called io.github or Squint Sail.js Cherry latest SHA deps file bb. So I will add Cherry, which is the ClojureScript compiler that I'm working on, to bb Eden. And you will see it here. So this is, by the way, how you can use add a Git dependency to your project using Neil. Now, what I can do is go into Babashka and require cherry.compiler. Cherry. Oh. Okay, there is a bug at the moment, but the idea is that you can use it from here. Okay, that's a demo effect. But So if you, the idea is also that if you have like a example.cljs file, you have, for example, you want to write a React component. In JavaScript, you normally do this in JSX. So what you can do in Cherry is, this is my application, and now I want to have some JSX, right? Or words. These are some words. So it supports a JavaScript destructuring. Keys, words. And now I want to map string over the words or something, or whatever. So the idea is that I can, now this is a bad example, by the way, but
string join.
Yeah, but let me simplify this.
Yeah.
So the idea is that you can write JSX directly in your JavaScript without any other tools. So now I can do Cherry and then this example file. Now it has compiled it now. So if I inspect this JSX file, you can see it. Okay, now it has var app function x, and then this is the JSX. And actually, I have a nice example of this in a presentation that I recently gave. Let's see if I speak. What is the slide? Speaker deck. Yeah. I can show that slide maybe. Zoom in. Or where is my next? Oh yeah, no. How do I go to the next one? Okay, so yeah, so this is a nice example where you, okay, this is kind of like the example that I just had, but the only dependency here is React DOM server, and we can do server-side rendering using this. So if you compile this and then run it with Bun, which is a new JavaScript runtime, this is all the code that you need to render this from a web server. And so you can reuse your components on the front end and in the back end and stuff like that. So the idea is to be more lightweight ClojureScript compiler, which works more closer with the JavaScript tooling.
Yeah, amazing.
So if you go, the website is here, squint sales.js/cherry. That is the ClojureScript compiler. And there is also a project called Squint, which is, it uses ClojureScript syntax, but it compiles directly to JavaScript. So it doesn't have the immutable data structures. So if you really need a small output without any ClojureScript stuff in it, then you can use Squint, which also has some nice use cases. So that's what I'm currently, it's the experimental things that I'm working on. Yeah.
Interesting. So good luck with the experiments.
Thank you.
Awaiting something new, Okay, thank you, Michel. So hope to see you next time.
Yeah, thanks for having me.
And thank you for all of your work for the Clojure community as well.
Happy to do it.